Okay, and at the end of the presentation, I'm going to bring up our CTO, Magnus Feuer, and so you'll get to meet him. He's a noob as an Erlang programmer, although an extremely experienced C++ programmer. I'm going to talk a little bit about connected devices, but not so terribly much, since at least for those of you who attended the keynote this morning, that was like an excellent warm-up to what I was going to talk about. And after that, I'm going to talk about what we're building in our company, a service called Exosense. And since this is a programmer conference and an open source conference, I'm going to talk specifically about how we want to relate to the community. And after that, Magnus is going to tell you a few things about our first customer project. Now, to set things off, the CEO at Ericsson told their shareholders that by 2020 they expect to have 50 billion connected devices. Basically saying anything that could benefit from being connected will be connected. Like nowadays, we mostly have the iPhones, laptops. Now, that sounds like a lot. Of course, IBM came out with a projection of 300 billion, and this morning we heard Jim Zemlin say 1 trillion. In any case, there seems to be some agreement that there will be many. Now the question is, what will these do? Most likely we have no idea. We can imagine some uses, but this is simply a market that's set to explode because now the conditions are right for doing this, finally. Now, obviously for hackers and entrepreneurs, this is good times. So we can just jump in, we can pick our favorite little commodity Linux box. That's a Q box right there, a media server, 3 watts, fits in your hand. Install Erlang on them, takes a minute or two, and then just start hacking some applications. Now, it's a little bit more complicated than that, obviously, because device programming has always been a little bit complicated. It's a lot of tinkering, but that's fun. But when we talk about connected devices, we get a lot of connectivity issues that create complexity. Now for this room, this is not so hard because this is what we love to do, right? Erlang is a coordination language. So dealing with data flows from sensors and talking to the cloud, that's the fun stuff. Now for most other people, this will be scary, and they probably don't have any idea, unless they've tried, how badly this is going to wreck their architecture. But they usually find out gradually as the pain increases. Now you will have failure modes, like having to switch between different modes of connectivity dropping out as you move out of coverage. And then if you're lucky and you get lots of devices out in the field, you have the problem of remote updates, remote debugging, all kinds of stuff. Now, all of this creates what is in practice a very high barrier of entry if you want to try to do this for real. There are also challenges in the back end. Now, if you're going to have a good service and lifecycle support, you have to factor in that you will have different versions of your devices out in the field. You will have to be able to support different versions of protocols, board types, software versions, capabilities. And you will probably also need to, in telecoms, we used to talk about northbound interfaces. I think that was because they were always at the top of the sort of network map. And that was for interfaces to network management, network operation control centers, profiling services, perhaps, like boundary service, but also interfaces to business logic. And of course, you're going to have versioning. You're going to have some kind of modularity and an approach for that. Upgrade schedules. If you have thousands of devices out there, you're not going to be able to just push a firmware upgrade to all of them at the same time. So you're going to have to stagger upgrades. You're going to have to worry about, well, in telecoms, we called it knockout units. If you push a bad upgrade out there, how many devices do you want to kill in one fell swoop before you realize that you've done something wrong? Bandwidth metering. If you're connecting over mobile internet, for example, you may actually have different data rate plans. There may be times in the day where you don't want to push large amounts of data. These are things you have to worry about. And all the other things in a backend service, like persistence, scalability, redundancy. Now, these are issues that we plan to address with what we call Exosense. And the idea is to provide an end-to-end solution, basically from the sensor out into the cloud and the customers or your business logic. Now, this is the community pitch, so I'm going to talk to you as potential developers in this. Feuerlabs is a small enough company that we can all fit on one slide. We formed the company in November last year, so this is pretty early days still. Some of you may know at least some of the faces. That's me up there. Marcus Taylor is our CEO. He used to be the CEO of Erlang Solutions. Before that, he was at Logica. Has done startups on mobile communications before. Magnus Feuer has been working with telematics for a long time, Volvo wireless car, and he can tell you everything about the horrors of doing this kind of thing in C++ because he's done it several times. Tony Rogvall, I don't know how many of you who know him. He joined the computer science lab in '93, worked there for a number of years. Then he was one of the people who founded Bluetail, which was then bought by Alteon, which was bought by Nortel. And then he went from there and founded Synapse, which pioneered over-the-air configuration of mobile phones. I think by now they've configured about 1 billion mobile phones. And a number of other ventures as well. So I think together we have quite a few decades worth of experience doing this sort of thing. And that pretty much means that we know what challenges are ahead of us, which is a good thing. It also means that we know what challenges are ahead of us and that we're in for quite a lot of work. But that's the fun stuff, right? Partners are Motivo, which is an expert company working with, they build concept cars, help automobile manufacturers, designing drivetrains, battery systems. Erlang Solutions, an investing partner. The backdrop there is actually a performance display that Magnus and Tony did in a past venture called Magden. And we're actually porting that graphics package to Erlang so that part of this solution will be a touchscreen display for high-performance graphics in an embedded environment. We're not quite ready to release that yet, but it's going to be part of the open source release. So a schematic for what this looks like. You have the device application, which is essentially, well, some components for data acquisition, drivers for various types of interfaces, a link to the backend system, and logic for handling configurations and upgrades and things like that. So the idea is you put your application on top there and you build on all this to get going really quickly. And on the back end, we have links to the business logic and also monitoring, operation and maintenance, the typical stuff. So the value proposition is that we're pretty sure that we're going to offer quite a lowered entry threshold for people who want to get into this business and do exciting things with connected devices, and much shorter time to market. Depending on how complex your application is, you get some reference hardware, $100 or so might get you started. Get it up and going. You should be connected to the back end first day, and then start testing and prototyping your application from there. Now, given that you're getting so much for free and stable logic, and you don't have to reinvent all these things, and also if you're using Erlang on the device end, you get a lot of the inherent quality of Erlang and OTP pretty much for free. So, and also we're building the back end to be highly scalable. So the plan is to be able to cope with millions of devices, up to perhaps hundreds of millions of devices. Obviously not from day one. But that's a lot of what we're putting together now are, taking the experiences from what we've done before and trying to really have the scalable solutions for that kind of volume. Now, the Erlang benefits, for people who are not used to Erlang, this is kind of a hard sell, because a lot of people are used to thinking that it doesn't really matter what language you use. You can program anything in Fortran and so on. But to us, Erlang is the perfect fit for device application development nowadays. As devices are going multi-core, Erlang is a perfect fit for that. Just naturally expands to multi-core. And multi-core system on a chip designs that you have today with integrated GPUs, DSPs, actually pose a lot of challenges for a programmer if you want to really make use of those. And we believe that we can provide a lot of very good abstractions for automatically making use of this. Now, what this translates to in the embedded world, it's not so much performance, it's battery life, it's low power. The best way to keep the power down and still get good performance is to go multi-core. Now, debugging, anyone who's tried to debug a multi-threaded C++ application in a tight embedded device that doesn't have a TTY, doesn't have a disk, you can't dump core, will probably agree that debugging an Erlang application is slightly easier. We will also make use of the facilities in Erlang for breaking up the upgrade path. Essentially, just by going into a functional language or a language like Erlang, you kind of shift the balance between code and data. So a lot of what would normally be code updates will rather be data changes. We can obviously do hot code loading of modules and things like that. And the abstractions for connectivity, I've talked about that in other presentations at other conferences, how this really, with Erlang, the abstractions you have there, you actually can contain the complexity so that adding a new interface, adding a new protocol really doesn't mess up your other code. So you really get true modularity in the communication aspects, which is extremely good and also allows you to maintain your quality over time, even as you add features. Now, this is very often not the case when you start adding new features. You get interaction with old features, and things that actually worked before suddenly don't work anymore. And that's something that we usually do not see in Erlang. So the open source idea here is that, well, on the service side, as usual, we will consider that closed source. Now, that obviously doesn't mean that we're going to write everything from scratch and we're not going to show any of it to the world. We're going to make extensive use of the best open source components, and we're also going to release open source components that we build ourselves. The source will be secret, essentially. And now this is also for practical reasons. You don't really gain much from releasing everything as open source. Because really, if you want to release something for others to use, you need to document it in a different way. And so by doing so, not only do you open up for competitors in a way that you may not want, but it also takes a lot of extra time that doesn't really buy you that much. On the device side, on the other hand, we plan to make just about everything open source. The connectivity module there, we'll see while we do that. But essentially, there is no point in making it anything proprietary. But obviously, it has to be possible to put proprietary code on there, because you want to make money on the products you build on this, right? So you want to be able to have proprietary code mixed into this. So that, of course, will affect the licenses we pick. Same thing with the backend side, the business logic. Obviously, that is the customer's IP and not something we worry about. So the idea is you get a free download. It's all ready to use. We will pre-test it with some reference hardware. You should get maybe up to 10 devices managed for free, so you can register and at no cost get up and running. So again, the idea here is to really stimulate your innovation and make it as easy as possible for you to connect. If you get successful, if you actually start having customers and you start selling these things, then there will be a progressive licensing scheme that also gives volume discounts as you start entering the millions of devices, which of course you will. Now the back end, you can either license it for self-hosting or you can connect to it as a service. So the device platform is not just us. It's actually several companies within the Erlang community that are already working in this domain. So TravelPing, for example, has packaged, done embedded packaging of Linux for quite a while. And we have found that we have a lot of things in common in terms of the technology choices that we've made. So essentially, we've pretty much agreed from the start, even as we started talking to each other about how these things should be built. We're also cooperating with TALEF, who are active in the standardization of netconf. And so I'm going to get back to that. And also ESL, we're using ESL's embedded Erlang distro. Just copy it down onto the ARM device and you unpack it and you're up and running. It's very, very nice. And also we have with ESL the knowledge partner transfership in the UK, which you're going to hear more about at the EUC if you go there in May, where the idea is to work with embedded device manufacturers and also the community to further strengthen Erlang's position in the embedded world. Now, as I said, we incorporated in November, so we haven't really been at this for so long, but I thought I'd show you some of the things, design choices that we've made and some of the things that we've published so far. We've chosen for the data modeling, and this is actually a key thing in order to have some discipline in the configuration management. We've chosen something called Yang. It's a standard that it comes out of the netconf. If you don't know netconf, it's actually quite a nice configuration management protocol. So this is an extract of what Yang looks like. We have published a Yang parser. I think you have the link down there, together with TailF. And using that, we also generate JSON APIs for the RPCs from the business logic side. And we also, so we generate markdown documents specifying, illustrating the API. We also generate code to automatically verify incoming JSON requests and do type checking and type conversion both on the incoming and outgoing side. And I think this is actually something that you could look at even for web applications. I mean, there are a few ways to try to validate your JSON, and this works really well, actually. So another tricky problem is you have to have persistent store and forward, because when requests come in, you don't really know if the devices are going to be online. And you can't just drop requests, and you have to make sure that you actually do things in order. So we've developed a little key value database that we call KVDB, as if you all thought that you needed another key value database, right? It's actually LevelDB, or it's a thin layer on top of LevelDB for the backend and SQLite on the device side. LevelDB is great, but it uses tons of open files, which is not necessarily a great thing on a tiny embedded device. Whereas SQLite uses one single file for the entire database. It's not that fast, which is a bad thing on the back end. But we have the same API, the same semantics. So one of the things that we do is persistent queuing. And we feel that we've engineered those queues so that we can actually have millions of queues. We imagine, or we will have at least 2 queues per device, one for incoming requests and one for outgoing. So basically, we do the automatic validation and conversion, and it gets put in the queue using gproc pubsub, actually, and update triggers in the database. We will trigger a dispatcher when the queue goes from empty to non-empty, which will spawn a process that deals with the queue. It also obviously has to check if the device is online so you can talk to it. Of course, when the device comes online, you will trigger the same process and it gets to check if there is something in the queue and so on. This is working really well. Now, a little tweak is that you don't really extract the data or delete the request from the queue until you actually know that it succeeds. And then, of course, so then you can retry if there are bugs or whatever, and you need to have a limited retry so that you don't just halt all progress to the device, so that eventually you will have to act on the fact that maybe a request cannot be served and you have requests backing up. We also have some tweaks for the configuration data management. Now this is a fairly busy slide. You don't have to parse it all. What we've done is we feel that we've come up with a pretty good representation to be able to store configuration data trees and efficiently iterate over trees or iterate over subtrees. Now we also have a diff function. This is actually a little test function that performs a diff on the data tree so that you can see exactly what's changed. And of course the idea of that is that to save bandwidth in the communications with the devices. Now, we also have made a serial line driver. There are a few serial line drivers before. This is actually going to work on Windows. It doesn't quite work on Windows yet, but almost. Windows is pretty nasty with overlapped I/O and everything, but it's almost there. It's very similar to GenTCP. So you open it with similar to GenTCP options, like you can put it in packet mode, so you get one line at a time. You have active once semantics, so you get the automatic flow control. You can set the baud rate and buffers and things like that. And so just like with GenTCP, you get the incoming data as a message. You can set options just like with GenTCP, and then you can just use normal pattern matching and everything, just like you're used to doing. And of course, you have a separate process for doing this. It doesn't have to worry about interleaving with other things. Plain Erlang stuff. And it, of course, works beautifully for this. This particular thing is collecting waypoints from a GPS feed. Now, we're using Rebar, and it's great, but of course, you have to hack it a little bit, and we offer some contributions back. One of the things we wanted to do was, because we got tired of having Rebar check the deps and pulling down from GitHub all the time, so we wanted a way to, at least in development mode, tell Rebar that we were just wanted to use the erlibs path. And so then we came up with a way to patch the Rebar config. So you just put a rebar config.script, and then at least our version of Rebar will pick that up and use the file:"script command. If you don't know what it does pretty much the same thing as file eval, but it returns the last value evaluated. So what this does is it reads the Rebar config, checks if I've set the environment variable Rebar deps, and then patches the configuration to that dependency directory. So then we just have our code, and it goes directly to that instead of going to GitHub. Now, obviously, you have to remember to turn this off when you're building the actual target system. Now, also, we were too impatient to wait for Rebar generate, and also annoyed with the fact that it copies all the modules to a separate directory, which makes it difficult to patch the code. So I had a little application from before called setup. I tweaked it a little bit so that it can now read a reltool config file, but then pretty much from there just builds, goes to systools and builds boot scripts. And this takes about a second, and then you're up and running against your development sources. But everything else is just same Rebar configuration. And we think this works really well. You know, it's like Mike was talking about yesterday. You know, all the seconds you can shave off this turnaround in your development is good stuff. So this is pretty much what we've had time for so far. We actually have a system up and running. And we're going to be documenting and publishing some of these components. And we're trying to send pull requests to other projects, obviously, and make use of your stuff as much as we can. So that's kind of the story. And we're hoping that you will come up with great ideas for how to do this, how to build applications on top of this, and then make use of this service so you don't have to reinvent the wheel with device management. That would be like 90% of the work you will have to do otherwise. So this will let you focus on your core application and have everything just work. Now I'm going to turn over to Magnus Feuer, who gets to go up and actually take my mic.
I can take the wireless one.
No, this one, because otherwise it doesn't go into the camera.
1 second. Hello, I'm Magnus Feuer. I was CEO of Feuerlabs up until Tuesday, when I happily got demoted to CTO and Marcus Taylor took over. So basically my role in the company is to, in time, start to get hacking actually on Erlang as well. I've been far too busy with company formation and chasing clients, etc. up until now. But hopefully I can switch back to technology, which is really where I thrive and are a happy guy. So I'm here to introduce our launch client, which we actually signed off for a while back. It's called GetAround, a local company here in San Francisco. They do peer-to-peer car sharing or car rental. And basically, very short story is that if you have a car and it's parked outside your office, you can rent it out to somebody else in the same peer-to-peer car sharing network on an hourly basis. They can come up to the car, use their smartphone to unlock it. First they reserve it, they unlock it, they drive around, run a few errands while you're still at your office, come back to the office, drop off the car, lock it, and when it's time for you to go home, your car is there, and you're now $50 richer, for example. So GetAround and we started working a couple of months ago, and they're our launch clients. It's a full production contract, so it's not a prototype or a demo or something like that. It's basically full on. We deployed a prototype server for internal testing with GetAround, and it's moving forward very nicely. So I'm here to kind of describe a bit of the use case of GetAround and what we're doing for them, and also what we're not doing. So I didn't have time to modify this for GetAround's case. So basically what we provide is only the server side in this case. So they license the server, pays a bit of money, and what we do is that we manage all traffic to their devices, which is called the car kit. And so they're not running Exosense in their end. It's an in-house developed hardware and software solution that we are interfacing by implementing their proprietary protocol, which is pretty cool. We started talking actually this week about, you should try Exosense on the device side. It's pretty cool. And the initial response was, Erlang scares me. So we have a bit of selling to do there, but we'll see what we can get around to. So what we are is that we're basically the communication router for all the vehicles that are managed by the GetAround car service or the peer-to-peer rental. It's no application logic. We're not the magic sauce in any way. The only thing we're doing is the nitty-gritty and boring details of making sure that we can communicate with the vehicles, that we can push updates to it, that when the vehicle calls in, that we can receive the data, that we can unlock the vehicle, that we can receive waypoints for the vehicle and see where it is. But we take all this data as it comes in and simply forwards it to the business logic that is written and maintained, obviously, by GetAround as well. So what we can do is that we can modify. What we're trying to do is to minimize. We want to be able to kind of manage the device in such a fine-grained detail as the device itself allows. So what we can do is we can do a lot of configuration updates on the device on how often to report in and how often to transmit waypoints, etc. So we can fine-tune how much bandwidth we're using. because this little bandwidth here is very constricted and extremely expensive. So we need to try to compact the data as much as possible using gzip and deltas and everything else, but we also need to go beyond that in order to figure out, and this is a generic problem, it's not only GetAround, all our clients have this issue. We need to figure out, for example, ooh, this is too expensive, we keep blowing our data plan, we spoke about data metering earlier. Let's lower the waypoint interval from once every 5 miles to once every 10 miles, or once every 20 minutes, depending on how you want to set it up. So we can kind of tweak not only how often things go in, but the actual density of the data itself. And that's kind of crucial to be able to do that over the air and tweak things as you move along. And as you start to shift into production and you see, ooh, here, we blow 60% of our data budget every month on stupid call-ins that occur, the device calls home once every 10 minutes. Let's extend that so it calls home once every 30 minutes, for example. So all this is standard functionality that's built into the Exosense server. And what we do is that we, through our little protocol adapter that talks to the CarKit protocol to the device itself, we shift and we adapt, and so we can push those specific configuration data elements out to the CarKit itself. So things we can do, the standard stuff is configuration updates and store and forward and bandwidth metering and things like that. And then we have a few CarKit specifics on top of that, such as door unlock, door lock, and a few other things. There's a kill switch, for example, so you can disable the vehicle in case somebody steals it. And then the other way, the massive data going from the CarKit up to the server is waypoint data, because you want to be able to see where your car is. If it's not in the parking lot when you go home, you wonder, hey, I need to track this. So that's pretty much it. It's a fairly standard system from our point of view. There's a bit of extras in it, but all the magic sauce is outside us, and we see this just as a kind of a traffic management system from our point of view. And what we managed to do, what we did was that we took our standard Yang spec, which Ulf described earlier, and we extended it with CarKit-specific commands that are not a part of our standard command protocol set, generated a JSON command set out of that, or JSON specification out of that, and exposed that and shipped it over to GetAround and said, here's our suggested JSON API that you can use, and they will then implement that straight off. So having a Yang-centric configuration or Yang-centric specification system is fairly crucial in order to kind of single source how you generate configuration data, how you structure your configuration data, how you structure your RPC commands, and also the interaction with the backend application server. I think that's pretty much it, and we have 2 minutes left. So plus questions. I think we can jump to questions right now. I can talk more broadly what we want to achieve if there are any questions about that, or if you have any questions for Ulf as well. Yes?
What markets are you targeting?
Initially automotive, because Motivo, which is one of our founders, have a very strong connection to OEs and the new breed of low volume automotive manufacturers, such as Koda, Tesla, Fisker, and a bunch of other people. So, Motiv are developing actually the drivetrains for a lot of these vehicles. And Motiv also develops smart energy systems such as peak shavers, huge container, fill them up with lithium-ion batteries. You now have 2 megawatt hours in a container that can pump energy into the grid at peak hours and kind of absorb energy during off-peak hours in order to kind of level the entire, so to level off the load on the power generators themselves. All these things needs monitoring. So for the new low volume automotive manufacturer, especially the electric ones, telematics is not an option. Every single car needs to be connected, even if the end user, the driver itself, is not interested in telematics per se. The manufacturer are interested. And for example, the insurance company is interested as well, because if you look at the battery pack in an electric vehicle, today it's about 30% of the total cost of the vehicle. It's about $10,000 for a complete battery pack in a Nissan Leaf. The residual value of this car, or of the battery pack, at the end of the life, after 3 years, for example, if you lease it or after 5 years, is completely dependent on how it's been used. How deeply did you discharge it? How many charge cycles has it gone through? Has it seen overheating? Anything like that. The insurance companies are extremely interested if they salvage a car to see how much money can we get for this battery pack that we now salvage, because that determines in which secondary market you can put it. So that's a typical use case for us as well. Energy grids is obvious. You need to monitor these peak shavers very closely because there's a vast amount of energy in there. You don't want anything to go wrong at all. So those are our two initial markets. But we really see, on a broader scale, we see the world as a set of connected sensors that needs monitoring, management, configuration, and you need to push new software to it and all that. So as soon as you have a sensor that you need to manage remotely through our device manager, we'd like to be there on the service side and possibly also on the device side. Yes?
You're talking about the sensor, but I'm not aware about any sensor capable to run Erlang.
No, so what we do is that on this unit, this could be an ARM7 unit, for example, ARM v7, we have a data acquisition chipset on it, an AD converter, 10-bit, something like that. So what we do is that we have a Linux driver for that. We then add a normalizing Erlang module on top of that, as a driver or something like that, that delivers the data in a normalized format. So that means that you can read the sensor package at the bottom, you feed it through the Linux device driver and through the Erlang driver and have it presented in a standard format.
So what you call in device application actually is sensor gateway?
So the device application can read the sensor, it can read GPIOs, it can read, anything basically, and access all that data in a very easy way through a kind of coherent API, if you want to call it that, or through a coherent interface. And that means that we are on our first step of becoming hardware agnostic. If you replace the data acquisition chipset, you get new Linux device driver, you may have to tweak the Erlang driver a bit on top of that, but the application should not have to change.
Now we also have, you could actually also have a sensor gateway. I know you could talk to Tony, for example, about his other venture, C-Zone, where he essentially has that, a number of very tiny devices that you could not run Erlang on, you wouldn't want to, and then basically one gateway node that is running Erlang and handles sort of the more higher level logic, and then that node itself would not have any sensors necessarily, but it's the point of contact with.
So this is not a hard real-time system. Erlang is not there, period. It's a soft real-time system. It's a management system. So in the device here, you can kind of do the high-level communication. You can aggregate data from sensors or from other control units. And you can kind of monitor them and manage them. But this is a high-level system from an embedded point of view at this point.
And second question, maybe I missed, but what's the actual protocol, wire protocol?
This is called XSupport, and it's an BERT RPC-based protocol.
Is it open? Or?
It's going to be open, I think so. We mark this as closed source, but I'm leaning more and more toward opening it. So, Yes?
How big is the footprint as far as on the device?
We haven't built it yet, so we don't know. We're aiming at 8 meg flash and 32 meg RAM. So that's the kind of the starting point for an embedded system. Obviously, you can't pack too much on top of that, such as graphics, etc. But that's where we're working with Travel Ping, because they've done a lot more on the hardcore embedded work and getting.
How much flash did you say?
8 megs of flash and 30. Yes.
This isn't targeted to like electric meters and stuff like that.
Yes, that's the very low end. I mean, no graphics, no fancy stuff at all. Obviously, no massive storage at all.
Now, on a trillion device market, we think that we still will cover a fair bit, but it's not. It will not be the tiniest devices.
No, I mean we run a VM on top of it. We will never compete directly with the low-level microcontrollers. Yes.
So certainly I see in your business model the advantage of Erlang on the device side in this connected device space. What's the advantage of having Erlang on an embedded device if you're not connected? Is there any reason to use Erlang versus?
my initial question is, why would you not be connected? But I see there are reasons.
There's a lot of embedded devices today that are not.
Yes, I'd say that it's a shorter time to market, and if you use the kind of Exosense device side, you can start application development immediately without having to worrying about device drivers and libraries and aggregating everything. And also, during the development cycle, you can run a simulated environment that's almost identical, I say almost because it's never totally identical, to the device target. And once it runs there on your simulated environment, you can just drop it on to the target device and it should behave identically. And if it doesn't, to update the code is trivial in comparison with generating a new firmware, putting it on a file system image, dropping it in there, loading it, etc., with everything else.
Oh, I did have on one of the slides, but I actually didn't speak to it, was that this XSupport component is just an add-on on the Exosense device platform. So just like Magnus said, you don't have to be connected.
Yep.
And you don't have to be connected to Exosense. It's just our share of, we're going to do our share in helping Erlang become a really good device programming platform.
Yeah, you're free to develop your own device management system. I believe, there's a lot of questions there. I think you were first.
Yeah, so what's like the visibility between like devices on the same network? So is there kind of like, are they addressable between each other?
Yes, but you obviously have to go through the application, through the Exosense server. So if device A here wants to speak to device B, hypothetically, it would probably go through the Exosense server, maybe up through the application server because we're just a router, which would then forward the request down there. Peer-to-peer communication in mobile and kind of a GPRS connected device environment is very, very hard to do because the IP addresses are often totally unknown and they shift very quickly as well.
But if you can think of a way to do that, I mean, you could possibly orchestrate it using this Exosense connection and then take it from there and do something that's, well, from our point of view, completely out of band.
Yeah.
And we're not going to come gunning for you or anything.
No. Yes, I think you in the gray jacket.
Kind of we passed it, but the channel is you can abstract the channel, and if you do, then there's not unconnected device. The only difference is the bandwidth of the channel and the duty cycle.
Yes.
So if you're wandering around with a USB plug and plugging in every 10 days, there's still a communications channel. If there's a human being that's reading a meter and then writing something down and somebody else keys it in, there's still a channel.
Yeah, it's a sneaker network, basically, if you remember that term. Yeah.
It's a channel, and the only difference is bandwidth, delay, and duty cycle.
I haven't thought about it, but I think we actually can integrate that. So this basically becomes an extremely long latency batch-oriented protocol where you kind of plug in, remove, and plug in at the other end. Yes, I'd do Joe on seniority.
So easy code upgrade also introduces the risk of malicious code upgrade.
Yes.
How are you handling security?
So one of the core things we want to do, just to kind of digress a little bit, is that we want to break up the monolithic image of firmware as a magic black box that you always pray a bit extra before you start upgrading. You may brick it, you may push out something that's unstable, there's no rollback in case you fail, you may lose communication due to bricking, and you have to send some poor sod out into Alaska to kind of, unscrew and install something new. So what we want to do is that we want to kind of break this into smaller components where you can install a monitor ad hoc as the system is out and running by basically pushing it from the application server. You push an Erlang code out here and it starts executing as a monitor, looking for an overheating condition that you think may exist or not. So we're breaking it up a bit. Now this has to be done in a secure manner. And so what we do is that it depends a bit on how this is set up. Obviously everything is encrypted. It goes without saying with authentication, etc. And so there are two things. First of all, in the device, here we have device keys, and it will only accept incoming data and incoming upgrades and incoming code that matches the signature, that passes all the tests, basically. And also here, it's a question of data integrity between customers. So if you really want to make sure that you have the data and nobody else can see it, buy a license and host it yourself. If you don't care at all, you just want to run a demo, run our shared hosting service and set up a license there and provision a few devices there. We cannot we will tell you that you won't see your other neighbors' devices or anything like that, but we cannot guarantee it because it's a shared node. Somebody may crack it, we simply don't know. Or you can ask us to host a dedicated server, which is kind of the next step up. So, yes.
I think we're out of time.
I think so too. I'm sorry.
Just so that everybody can go and break.
Oh, no, it's
I'll
fine.
be at the Lounge.
Yeah, and I'm here to answer questions if there's anything as well. Thank you very much.
Okay.